Hello, everyone. So this class, we're going to continue with our discussion on the computational methods in engineering. And specifically, we're going to enter a new chapter, which is the built-in MATLAB functions. So as we mentioned before, we talked about the Excel, right? Excel has a lot of functions embedded, right? Even if you think about your calculator, there are basically some functions that come in handy, right? Where it can help us solve a lot of problems. So here we're just going to go through some of the common or the most widely used MATLAB functions which are built in the system, right? So which can be helpful for you to solve engineering problems. So what is a built-in function, right? The built-in function is a computational expression that uses one or more input values to produce an output value. So basically, this is definition of a function, right? So the MATLAB functions have three components: input, output, and name, right? So here, specifically, we're using the tangent equation or tangent function as an example. So here, the x is the input, right? B is the output, and tangent is a name. Okay, so this is basically an example of a built-in function in MATLAB. So to try to use this built-in function, for example, if you know the value of x, you want to find out the tangent of x, right? So then you can just first define, right? X equals, let's say let's do 0, right? And then to get the b, you just need to type in tangent, the name of the function, and then put x inside, you get 0. Tangent of pi over 2, which is 90 degrees, should be an infinite value, which is why it's giving you a significantly bigger value. Okay. So this is the definition of a built-in function in MATLAB, right? So basically, the functions will take the form of variable equals the function of number or variable inside. And the MATLAB has many, many functions that are stored in its file system. So basically, you don't need to. So most of the case, you don't need to define new functions for yourself unless you want to, for example, design a specific problem or specific function. And even under that situation, you can still use the built-in function in MATLAB, right? So for example, if you are trying to calculate the square root of something, right? So square root of value. So for example, we can just use sqrt of 9, right? It's going to give you 3. And another way to solve the square root is you can also do the power, right? The square root is 0.5, right? So that will also give you 3. There are some minor differences in the square root function and the power function, right? If you use this form to calculate the square root, so I think that's related to the complex number, which is sort of out of our boundary for our engineering classes, but we'll briefly talk about the complex number later on, right? So square root function is another function that we can use, but as I said, you could also use the power function, right? So for example, we're using tangent, we could also use sine, right? So if you know the x is already pi over 2, so sine of x, we know that's 1, right? A cosine of x is 0. Or at least it's a minimal number. So you could use a help feature to understand the function in more details. So for example, let me just clean everything on my screen. So if you don't know how to use a function, for example, later on we can see a function that's called fix, right? So this is basically to round certain numbers, but it has a special type of rounding, right? So we show that in Excel, you could also round, you could also do floor or seal, right? Fix is a type of round which round the number closest to 0, okay? So for basically for positive numbers, it's sort of like a floor function. But then for negative values, it's a seal function or ceiling function, right? So this is a fix, but you may not know what it means in the beginning. So then what you can do is you can just do help fix, right? So when you type this in, you can see that the function name actually changed to purple, right? So basically it tells you that the function or the purpose of this function is to round towards zero. So round fix x, round the element of x to the nearest integer towards zero, right? See also floor, round, or ceil, right? These are the functions that people can use for other types of rounding. So, well, you may wonder if we type in some random texts, right? So for example, if you type in my name and then it will say that it's not found unless you define a function later on. So for example, you can define a function by yourself called Carl Wang, and then it's going to give whatever help information or basically the commented information at the top of your function and then return that. We'll cover about user-defined function later on as well. But right now, let's just focus on the MATLAB built-in functions. Okay, so the earlier versions of MATLAB, basically you can see the entire help document that are stored basically on your local drive. So you can go through all the different topics. For example, if you just type in help, regarding the earlier options of versions of MATLAB, is going to give you the different topics like general functions, operators, right? So elementary mathematics, program language, elementary math functions, and so on and so forth. So you can check those functions locally on your computer. But I think for the more recent version of the MATLAB, you're going to see the message here, right? Which is the one that I copied here. So you can just click this this link here, hyperlink here, then it's going to give you the help. Let me see. Clear CLC. And then if you just type in, give me the CLC. So let me just type yeah, so it's just giving the help of the previous command. So I guess this is a little bit different compared to the Mac version of the MATLAB, right? So I think maybe for the Windows version of the MATLAB, when you type help, actually it's going to explain the previous command. But I mean, if you're using the Mac version of the MATLAB, if you type in help, then it's going to give you the hyperlink. So basically, it's going to guide you to the MATLAB website to help you with the different types of functions. So, for example, MATLAB help, right? So it's going to lead you actually to the MATLAB documentation, and then here you can find different topics. For example, the elementary mathematics, you can find it from the, I think it's a mathematics here, right? And then there's elementary math. And under elementary math, there are different types of functions. For example, we can go to the trigonometry functions, and then it's going to give you the sine, cosine, functions related to sine, functions related to cosine, tangent, and then second, cosecant, so on and so forth, right? And under each topic, there are different functions that we can use too. For example, there's sine function, which is the most common one. There is also the arc sine function, which is an inverse sine function. We'll talk about that later on too. So basically, if you don't know what certain function does, you can always go to the MATLAB and use the help function, right? So you can do help sine, right? It's going to give you the basic introduction of this function. And a lot of times, what we're trying to achieve is we're looking for a function, right? So we're trying to see if MATLAB has a function that can achieve certain tasks. So an easy way is actually just to go to Google and type in MATLAB and then describe the task you want to do. For example, if you want to find certain value inside a matrix, right? So you can just search MATLAB, and then find value in an array, and then a lot of times, I mean, it's gonna return you the website that's will help you with it. And one advantage for using MATLAB is that it has a very large user community, and then there are also a lot of discussions, right? For example, you can post questions, and then basically inside the community, people can help you with all of these different functions, right? So, which is can a lot of times can be very handy. Okay. So this is a help function, how to get help regarding MATLAB. And here we'll just give a few examples of the built-in MATLAB functions. So for example, the tangent function, we already showed that you can do help. And also you can do, for example, doc tangent, and then it's going to give you the hyperlink that has the information of the tangent function, right? It's the same for the other built-in functions in MATLAB as well. So now we can try a few functions which are built-in, right? So use the MATLAB to help find exponential, natural logarithm, and logarithm based on two functions. So for example, you want to calculate the e to the power 7, then you can just do exp 7. Right? You can do, for example, a equals exp 7. So this is the value you can get, right? If you want to get natural log, so then you will just do log 4. Okay, so this is something that we need to pay attention, because I think when we learn about the logarithm, right? So a lot of times we're dealing with log 10. For example, the log 10 of 100, 10 of 100 is 2, right? The log 10 of 1000 is 3. So, but when we're dealing with the natural log, actually people use the ln, right? But the thing is that in MATLAB, there's no such function called ln, or the ln could mean a different function. So let's see, we just search help ln. There's no ln function, right? Instead, in MATLAB or in other types of the computational tools, for example, also in the, I think in the Excel, it's the same too, right? So you will actually type in log. So log just means natural log, right? So if you, basically here, we don't have the E defined. So we can, for example, just put 2.7 something, right? That's the value of E, right? So then you can see that the log of 2.7 is close to 1. It's an, basically it's the constant, right? The natural log constant that people normally use. So this is something we need to pay attention. Basically, that if you want to do natural log, then you just type in log. But if you want to do log 10, right? Just the regular log 10, right? You will actually use a log 10 function, just like what I did over here. So this is I would say a major difference in terms of our handwriting, right? And the computational tool. So I also have a short note over here, right? So the log actually means the natural logs, logarithm. Okay, so you can also check the help navigator, right? So basically you can access the navigator and then try to look at basically different functions that are built in MATLAB. So here we'll just, in this class, we're going to demonstrate some examples of the built-in functions, right? And then also try to see how we can use these functions actually in a few of the engineering problems. So basically, MATLAB can help you perform all of the operations that you can, your calculator can do, and it can actually do much more, so much more than your calculator, right? Your calculator can't solve a function, or maybe some of them can solve very simple functions, but MATLAB, if you know how to program properly, you can solve almost all types of functions, right? At least numerically. So you can also search for topics of the elementary math or use a help navigator, right? So for example, we already did this. Square root of 9 is 3, natural log 7, 1.9. You can try a few others, right? So this is an example using the Clausius-Clapeyron equation. So Clausius-Clapeyron equation, I don't know if you have learned this in your chemistry. Basically, it links the temperature of certain liquid to the vapor pressure. So if you think about water, when you're boiling water, when the water temperature get to the boiling point, right, 100 degrees Celsius, then the vapor pressure of the water is just 1 atmosphere. That's why you see the lid of the pot is going to rise up and down, right? That's how we define the boiling temperature. But even at lower temperatures, the water is also going to have vapor pressure because it wants to escape from the water, from the liquid phase into the gas phase. right? So the Clausius-Clapeyron equation actually relates the saturation vapor pressure to the temperature. Okay, so here, for example, the P0, right? This is the pressure, right? And it's related to the temperature. Of course, it's dependent on a few other parameters. For example, P here, as we described, the saturation water vapor pressure, right, in millibar at temperature T. Delta HV is the latent heat of the vaporization water, which has the value of this, right? R air is a gas constant for moist air, that's 461 joule per kilogram. And then temperature is in Kelvin, is in K. Okay, so basically if you have, let's say 100 degrees Celsius, you have to convert it into Kelvin, right? The P here, you will see 1 atmosphere. Okay, so well, then basically this example, for this example problem, it wants us to build a table, right? Again, build a table that relates the temperature to the vapor pressure. But at the same time, since we're in the United States, actually it wants us to use the imperial units from -60 F Fahrenheit to 120 Fahrenheit. And use the Clausius-Clapeyron equation to find the saturation vapor pressure for temperature in this range. And then present your table as, or results as a table for Fahrenheit temperature and saturation vapor pressures. Okay. So this is basically using this function here. Of course, well, you can use your calculator, right, to find out what's the temperature at each location and then do the calculation. But here, we'll just do that in MATLAB, okay? So last class, we said that we could save our scripts by using the M file. Let's try to do that in this class too, right? So we can define, basically, right? We can do example 3.1. This is our comment. We can save it. So just as example, and then we change the name, 3, 1. Okay, so now we have saved our file. So later on, if you want to get back to this file, you can just double click and then it will show you the scripts. Okay, so basically we need to first type in some parameters. So we want to see what is a P here, but we need to find out what are the other parameters. So first, it says that the temperature is in the range of -6 to 60 Fahrenheit to 120 Fahrenheit. So we can define our temperature here. Let's just leave a few empty lines, right? Temperature equals -60. And then let's just use 10 as a gap to 120. You can also use 5 or so on, right? So this is actually the temperature in Fahrenheit. Let's just do F, okay? So then we can also type in the other parameters. For example, the HV equals 453 E6, right? So that will be latent heat, right, with the unit of joule per kilogram. And then there's also R air. Just type in R air. So 461, right? So we should note that MATLAB never recognizes units, okay? So we should not type in units in our numbers. Otherwise, it's going to recognize it as a string. So basically, this is gas constant for moist air, right? So we're trying to solve heat, okay? So this is what we have, what we need right now, okay? So then the other thing is, if we want to calculate the P here, you can see that we basically need to do an exponential calculation on both sides and then multiply this 6.11 to the right-hand side. Okay, so this is basically the calculation, or even if you use like pen and piece of paper, right? This is the calculation that you're going to do. But before that, let's check the units first, right? So the delta H and R here, both of them are using standard units, okay? So which is good for us. So let's say joule per kilogram. So actually these two can get canceled. And then the T here, it says that the temperature basically it should be having the unit of Kelvin, but right now we're having the unit of Fahrenheit. So I have to change the Fahrenheit into Kelvin. Okay, so luckily here we have the equation to basically do the conversion from Fahrenheit to Kelvin. So let's just type in here TK, right, equals T. Since we define this as TF, let's just do TF instead. Right? This is Fahrenheit. TF plus 459.6 divided by 1.8. Right, this is the temperature in K. Right, now with all of these inputs, we can start to calculate the P here. Right, so basically here, these two can get canceled, right? These two, we don't need to worry about the units because it already specified that the P, the saturation vapor pressure has a unit of millibar. Okay, so then to do the calculation, we just need to do exponential of the term on the right-hand side, right? So exp HV divided by R air, right? Multiply 1 over 273 minus 1 over TK. But now we need to pay attention because basically now TK is an array, right? We mentioned that for the array calculation, if we want to do the point by point calculation, we have to use, or element by element calculation, we have to add a dot over here, right? So the same thing over here, right? This is a dot calculation. And then since you already have the exponential, you just need to multiply 6.11, multiply by this term. Since this is a constant, we don't necessarily have to use the dot. But actually here, we don't need the dot either because HV and air are constants. So now we're going to have P0 equals this value, right? So to test whether this function works, by the way, I just saved the function. So now if you close it and then go back to example 3.1, you see the function working, right? So we can just click run and see what we get, okay? So basically we're getting a very, very big value here. So we need to pay attention. Basically, this is the delta H divided by R. And you can see that basically we have a lot of infinite numbers, right? So which means that there is probably something wrong with our calculation. So then here you can see that it actually gives us all the variables that we already calculated. So we can just quickly go through each of them. We have the TK here. TK is the temperature in Kelvin, as we mentioned. So it's 1 over TK. Let's see. Oh, so one thing, this is the thing that we didn't do well. So basically, you see, for this equation on the right-hand side, exponential term should be having this entire term inside the bracket, right? So we should be doing or adding another bracket outside this term, okay? So now if you run it again, you can have the p-value in basically in millibar, right? So, and then this is the p-value since this problem wants us to have a table, right? So you can see that the p right now is having the structure of the columns, right? So column 1 through column 19. So then to have the table, we said that basically TF is also having a one ray structure. So basically to do it, have more convenient demonstration, for example, with a table of 2 columns, then an easy way is to just do the transpose for TF in the beginning, right? So it's going to change TF into a single column, right? The TK is also going to be a single column, and then the P0, based on the calculation, is also going to be a single column. So you can click run again, and you can see that the P0 now has a single column format. So since this problem wants to have a table, right? So then you can just name table, for example, 3.1 is just PF and P0. Okay, so pay attention to the semicolon here. So the semicolon here, that we add is just to hide the output, right? If you don't have that, then it's going to show you all the output. Okay, so you can see the left-hand side, this is the basically temperature in Fahrenheit, and the right-hand side, this is the vapor pressure of the water in millibar. Okay, so this is some fundamental I would say the elementary mathematics, right? So to use the functions that sort of similar to your calculator. Okay, so then the next set of functions are the rounding functions. Inside the rounding functions, as we mentioned, it's just for rounding the numbers into however many digits we want, right? So we can just do the round. The round is just a common round. It's going to round, for example, either round up or round down, depending on how big it is, right? So if you round 16.3, then you're going to get 16, right? So round, let's say just do x equals 16.3, right? So if you do round x, so you have 16. If you do, let's say we also define y here, 3.9. If you do round y, you get 4, right? So fix, we already talked about that, right? So this is just rounding towards 0. So if you do fix of y, it's going to give you 3, right? So it's basically a floor function for the positive values. But if you do, let's say, fix minus 1.9, it's going to give you -1, right? Because this is now for the negative values, then it's sort of like a ceiling function, okay? And of course, MATLAB also has the floor function or ceiling function. You can definitely try that, right? And there are some other functions that can do additional calculations. For example, you can do the factorial calculation. So basically, it's the calculation. For example, if you do factorial factor 4, let's see, it should be factorial 4, right? It's just 4 multiplied by 3 multiplied by 2 multiplied by 1, right? So we know that it is actually 24, right? This is what factorial function does. Factor, I forgot what it means, but as we know, we can do help function, right? Factor. So factor n returns a vector containing the prime factors of n, right? So basically, if you do factor of, let's say factor of 10, it's going to give you 2 and 5, right? Factor of 12, 2, 2, and 3, right? It's only the prime numbers, right? So that's why 4 is not one of them, okay? So basically, this is a factor function, and then you can see there's also the rats function. I forgot what it means, but you can use the help. Rats, right? So it's a rational output. Use the rat to play the rational approximation to the elements of X, right? So for example, rats 4.2, rats, okay? So basically, I think this is what this function is trying to do, is to show that in the fractions, show each number, any number in fractions, and then showing the number in the rational format. So for example, 4.2, we know that it's 21 divided by 5. You could also do rats of pi, right? So we know that the pi is not a rational number, but actually, if you use rats, it can use a rational number to approximate the value of pi, right? So we probably won't be using these functions often in our calculations, but I mean, you never know, right? So there's also GCD, CD, 20, 10. I think this is trying to find out what's the common divisor, right? It's the common number that can be divided by both of the numbers. So we can do help GCD, right? So the greatest common divisor, right? So for example, you can do GCD 10 and 12, right? We know that both 10 and 12 can only be divided by 2, It's going to give you 2, right? So the greatest common divisor. And then LCM, you do help LCM. This is the least common multiple, right? So basically, it's going to be the number that are above these numbers, but they can, but can be divisible by the numbers you input over here, right? So for example, you can do LCM, just as this says, LCM 4 and 6, then you're going to have 12, right? Because 12 can be divided by 4, 12 can be divided by 6, right? It's divisible by these values, okay? So these are the functions, basically the discrete mathematic functions and rounding functions. And then we also showed the example of the trigonometric functions, right? We showed the tangent, we showed the sine. So one thing we just need to pay attention is that a lot of times we may say that it's sine 90 degree, right? The 90 degree is shown in degrees, but for the trigonometric functions in MATLAB, you have to use radians, right? So use pi, everything divided by pi. For example, 180 degree means 2 pi, right? 180 degree means pi. 360 degree means 2 pi, right? 90 degree is pi divided by 2, okay? So that's why pi is a built-in constant in MATLAB. You can directly type in pi over there, right? So, and another thing is the numerical computations with decimal point numbers are only approximates, right? So if you try to find the sine pi, you will only return this very small value, but not 0, mainly because pi is it's not a rational number, right? So it has a long number of digits after the decimal point, right? So that's why it's only approximation, because each of the number that you put into MATLAB is stored in a unit, right? It depends on the precision of the unit. It cannot go infinitely long, okay? So now if you try basically sine of pi, right? Sine pi over 2, it's 1, right? Mainly because it's approximation, right? We'll give you the 1. Okay, so this is a list of the trigonometric functions that you can try. This is degree to rad. It converts degrees to radians. So for example, if you have a degree of 10 degree, right? So you can just do degree to rad, then just type in 10. It's going to give you basically the form of pi, right? So 10 degree is pi multiplied by 1.1745, which is, you can do 180 multiplied by 0.1745. Oh, it's going to be pi, right? It's going to be pi. So, for example, if you do degree to rad of 90, right? This pi over 2. Okay. So you can also convert radian to degree, right? So you can do rad to degree. For example, pi over 2 is going to give you 90. Okay. Sine, cosine, tangent, arccosine, right? So it's an inverse sine, right? It's a hyperbolic sine, inverse hyperbolic. So these are, I would say, the more sophisticated functions that we may not use in our class. Okay, so some hands-on practices, right? So let me just clean the screen again. Use MATLAB to find the sine of 360 degrees. So you can do sine of the degree, but here you need to pay attention that this is degree, not the radian. So you can do degree to radian of 360. Okay, so which is a very, very small value, because we know that sine of 2 pi, it should be 0, right? So use MATLAB to find the arc cosine of, or the inverse cosine of -1 degrees. Okay, so you can just do a cos of -1. Right? It's actually giving you the pi value, right? Because we know that cosine 0 is 1, cosine pi is -1. So it's inverse cosine of -1. You're going to get pi here, right? So you can also do help, let's say, a cos right? It's the inverse cosine. Okay, so use MATLAB to find the inverse tangent of x as x ranges from -1 to 1 in steps of 0.1. So we can define this x first, right? So it's -1, 1 to 1, right? And then the inverse tangent is actually just a tangent of x. So this is the inverse tangent value. Okay. So yeah, these are the brief introduction of the trigonometric functions. We'll see if we can use them in our homework. Okay. So then the next is the set of the data analysis functions. So I would say these functions are quite important in our day-to-day practice or usage in the engineering problems, because normally we're dealing with large data sets, right? And then we have to basically manipulate the data, right? To control the data. For example, we want to find the maximum value, the minimum value, the mean value, median value, right? So as you can see, some of these names suggests the function, right? So this is similar to Excel that we introduced in the beginning. So you can find the max value, the minimum value, the mean value, median value. You can find the summation, you can find the product, right? So sort function, right? So we can talk about sort function later on. Size, how long the array or matrix is, the length, how long the length is, standard deviation, variation, and so on. Okay, so we can do some practice over here, right? So for example, x equals this array here, 5, 3, 7, 10, 4. So here that I didn't type in the comma because for the single column, right, comma or space are the same. So you have the x here. So of course you can do mean, right? So we can just run through these functions first. We can start from the max, right? Max x, we know it's 10, right? And then mean x, we know it's 3. The mean value, right? 5.8, median x, it's 5. Okay, so you may say that, well, you have a very short array. Why do you still have to use these functions? But in fact, in a lot of times, we're actually going to deal with large sets of data. It can be, say, thousands of them, right? So we can give an example. For example, we can generate a random set of number, right? So we can do 1001. It's basically an array of number. You can name it as x. Right, so this is the x. Now you have a large set of numbers. So now it could be the case. A lot of times, for example, it can be noise. We can talk about, we're actually going to talk about noise later on, how to use random number to represent noise. A lot of times we will deal with these large data sets. And now if you want to find the max, it may be troublesome, right? So you can see that there's like the row 3, you have 0.9, which is pretty big. 16, you have even bigger ones. But then are there even bigger ones? Or the same thing for the minimum. There's no way we can go through the data set just by checking the value one by one. So now if you use all of these functions again, right, see what you get. The max 0.996, minimum 0.0026, right? Mean is close because we're generating random numbers. The mean and median are actually close to 0.5. Okay, so you can also do sum of x, right? So these are all the random number we generated. So the prod, I think I need to check what the function does, right? The prod is a product of the vector x, right? If x is a matrix, P is a row vector with the product of each column. So basically, if here's an example. Let's try the example that we had earlier, x using the simple array, right? So let's see what we get from this x. The product or the prod is basically the product of all of these elements. But now, as this help section mentioned, if you have a matrix, things may be different, right? So if you have a matrix, let's say we just do y equals, or see, X. This is how we define X. Then we can do 1, 2, 3, 4, 5. Okay. So if you have a matrix, let's try product. Basically, it's going to do the calculation column by column, right? So instead of doing the row product, it's doing the column by column. But now, if you want to get the, for example, the product of everything in this matrix, what do we do? Just do prod of prod, right? Because now we have a single array, and if you do the product, then you get everything. This function of the prod. So there's also sort. So we can have, let's go back to the simple X again, right? Sort X. I think it's sorting from the minimum to the maximum, right? Sort rows. We can also try the complicated, right? 2 row, which is a matrix. And then let's try sort again. Okay. So basically I think it's sorting each column here, right? So it's doing the column calculation, it's sorting the smallest one to the first row. Okay. So we can also do sort rows. Let's seek for help first. Sort rows. So sort rows sorts the rows of matrix X in the ascending order as a group. B has the same size and the type as A. A must be a 2D matrix. So let's see if we have a matrix this time. And sort the rows X. Okay. So 1, 2, 3, 4, 5. I think it basically does the same thing. It does the same thing as the sort for the matrix, right? So these two are actually the same, at least from our function here, in sorting the matrix. Okay. So there are also functions that can provide you the general property of the matrix. For example, you can get the size of X. Right now, remember, size is the matrix here, right? It's going to give you 2, 5. So the first value is actually the number of columns. The second value is the number. The first value is the number of rows. The second value is the number of columns. And if you have, for example, the X being the simple array, and then if you do X, size X, you're going to get basically 1 row, 5 columns. You can also use the length function. It's directly giving you the how many elements are there in the array, right? If you know that it is an array. But now if you just define it as matrix again, and then try to use length of X, right? It's only giving you the number of columns, right? So it's not going to recognize the X as a matrix. Okay. So the length, basically the size will give you the number of rows and number of columns. And length will only give you the number of columns. Okay. So the STD and VAR are standard deviations and variance, right? So for example, if you have the X being a single array again, and then if you do STD of X, right? So standard deviation, variance of X, that's going to be the square of the standard deviation, right? You can try basically this thing to the power of 2 is going to be the variance, okay? So this is talking about an array. You can also do this calculation of matrix, right? STD of X, I believe it's going to, again, do the column-based calculation. And then if you want to get the standard deviation of everything, then you can use that. I think instead you have to convert it into an array, right? Because now the standard deviation of all the elements is not going to be the same as standard deviation of these 5 elements. Okay. So coming back to here, this is our example problem. So basically the max function can provide you with additional information. It's not only the max value, but also can give you the location of the maximum value, right? So if you do basically change the output as value, or let's say A, B equals max of X, let's see. I think we need to define X as an array again, right? So then you do AV max. So it will return you the value, which is 10, and also give you the location of the value 10, which is the fourth value in this array, right? So what is the median of the above vector? We already showed earlier. Median X 5, the sum of X 29, right? So now it's a standard deviation variance. I think we'll come back to the standard deviation variance later on when we talk about the statistics, right? So to give you a more in-depth introduction of these statistical calculations. But basically, standard deviation shows you how spread the set of values are, right? So if you have a large standard deviation, right, you can have a very spread values, right? Just like what's shown over here. If you have a small standard deviation, then the distribution is much narrower, which is like the one you showed over here. So here, this is showing you, I mean, we can try some additional functions, right? So for example, we can define V equals 2, 24, 53, 7, 84, 9, right? Y equals 2, 4, 56. Then this is basically a matrix, 3, 6, 88. So sort V in the descending order. So we can basically try sort V, right? This is the ascending order, right? If you want to do descending order, then we basically need to flip the function from left to right, right? So remember, we had that function of flip left to right. Okay, sort V. So then this is a descending order. Okay, so find the size of Y. We said earlier, it's going to, the Y is a matrix. It's going to give you the number of rows, first the rows and second the columns, 2, 3. Find the standard deviation of V. So just to do STDV, standard deviation, accumulated product of V, which is a prod function, V, right? Sort the rows of Y based on the third column. So I think maybe this is the sort rows function, what it does, what additionally it can do, right? So let's try the help sort rows again. Okay, so basically, if you type in the column number, it's going to sort the matrix according to the column specified, right, by the vector column. So basically, if you want to sort the column based on the sort the Y value based on the column 3, then you will do sort rows, then Y3. Okay, so it's going to, let's say if we show the Y again, right, it's going to sort this function based on the value of the third column. Okay, so I mean, this might not be that obvious. So let's try this way. So again, define a random number. Okay, rand 3. Okay, now if you do sort rows again, it's going to sort the entire matrix, actually sort the entire matrix based on the third row, right? This can come in handy, right? For example, when you have let's say multiple columns of values, right? So, and each column represents one person. For example, you have the height, the weight, let's say the personal information, the address, phone number, and then you have an important parameter. For example, the height, right, of a boy or of children, of a child, right? And then you have all the different child's name and everything. If you want to sort just based on the height of the child, and then you will actually use this column and sort everything, but you don't want to mix all of these parameters up, right? So it's only going to sort based on that specific column, which is the case here, right? So the Y originally has the set of parameters, right? For example, we can define this. Let's say this is the weight. This is the, let's say, the size of, let's say, the head circumference, right? Although I'm using some crazy numbers, This one can be the height. Okay, so you want to sort based on the height, but you don't want to mess up with the other columns. You want, for example, if you move this column, move this value to the top, you also want to move these values to the top. So then you will use the sort rows, specify the third column, and then you can see that the entire column is moved up. Entire row is moved up, right? So this is basically the sort rows function. I think MATLAB also has this function, and people actually use that quite a lot. Okay. So now we can deal with a data set that has a little bit more of an engineering or science background. Okay. So people will deal with the weather data. Weather data has quite a lot of data, right? So you can deal with, let's say, the past 20 years of data. Although here we're just analyzing 1 year of data. Okay. So we have extracted the precipitation information from the National Weather Service from one location, all of 1999, stored in a file called the weather data, XLS. Right? So actually, I save it as a rainfall. So if you want to open it up, it has the values here. So it's 1999 from January to December. This is the day number, right? This is the day number. And then basically this is the precipitation or the rainfall. Okay, so each row represents a month, so there are 12 rows. Each column represents a day, so there is 31 columns. As not every month has the same number of days, data missing for each column, basically the last several columns. Right? The precipitation information is presented in hundreds of an inch. So for example, it has this value, and then the data in the file contains only numbers. So it wants to do the following. So first, find the total precipitation in each month. Second, the total precipitation for the year. Third, the month and day on which maximum precipitation during the year was recorded. Okay, so what we can do is basically this is data set. Let's say we go to a new function. Let's do example 3.3. Save it as 3.3. Okay, so we can do let's say rain equals. So what I just did is I copied everything from this table, okay, to put it over here. So now basically you have the entire matrix of the rainfall data. So if you're curious, you can just run it, okay? So one thing that we need to pay attention to is basically here, you can see that it doesn't have all of these extra numbers, right? So it's going to tell you that the dimension doesn't match. So basically the dimension of array is being concatenated or not consistent. This is mainly because for the first month, there's no second month, right? February, there's no data over here. So one thing we can do is actually to just type in not a number. So as we mentioned earlier in this class, actually the MATLAB recognized not a number and infinity in its data operation. Okay, so we can again copy everything here. Okay. Paste. Right, so now you can see this is basically the data set we have. So we could also fill these blanks with 0, but I wouldn't say it's a good option, mainly because 0 means that there is a measurement. But we know that there's no measurement during, let's say, because there's no such a day of February 30th or February 31st, right? So the best practice still to use the not a number, okay? So basically you have the rain data, and then you want to, the problem wants you to find out what is the total precipitation in each month. So basically you want to do a summation of each row here, right? So before that, we can quickly find what is the rain, because the rain here is already over here, right? The rain parameter is already over here. So we can just try to do a sum let's say x equals sum of rate. Okay, so if you check the x value, actually it is doing the summation of each day, right? So we want the summation to be in the horizontal direction, not the vertical direction, because now it's going all the way to 31. Okay, so now then we can try to see if the help function can help us with doing the summation in the vertical way, right? So basically, actually has that. So you can do sum of dimension. So summation along the dimension dim, right? So because we have a matrix, it has the horizontal dimension, right, which is along the column, which is default as 1. You can also do the vertical summation, which is the dimension of 2. So now if you try x equals rain 2, which is along the vertical direction, you're going to have the value here, right? But the other thing you noticed is that, well, we can notice is that you see a lot of not a number here, right? Basically, here what happens is when you do the summation for each month, since you have the not a number, so the MATLAB is going to wonder, well, if you have a not a number here, when you do the summation, how are you going to add, let's say 62 with not a number? Are you going to get 62 or are you going to get not a number? So the default uh, result from directly summing the not a number with all the values is not a number. So that's why you can see that for the month that has 31 days, they have the total precipitation or total rainfall. But the ones with not a number in there, you're just going to get not a number. Okay. So then what can we do? Right. So basically MATLAB has a function called NaN sum. So NaN sum is going to ignore the not a number values. Okay. And another way to do the calculation is basically you can ignore not a number. So let's see if it's yeah, it's also showing here, right? So there's an option for us to omit not a number. Okay. So basically, if it contains not a number, it sums all of its not a number elements. So basically, and if you see, if all of the elements are not a number, then the result is 0. But we don't need to care about that for now. We can just do this and then add this option of not a number or of omit NaN, right? So you're going to get the same results. So I would suggest that we should use this format instead of the not a number sum, because I think in the earlier or newer version of MATLAB, this is not a recommended function anymore. Okay, so you can see basically the total precipitation is going to be sum rain 2 omit not a number, right? So the total precipitation for the year 1 year is just going to be the sum of the summation for each month, right? And then the third one, the months and day on which maximum precipitation during the year was recorded. Okay, so the months and days. So I think now we need to basically find the maximum, right? So we can directly try, for example, max of rain and see what it gets. Okay, so again, it's doing this this column, right? It's having this column selection, right? It's just finding the maximum value in each column. So you can do 2. Let's see. Search for help. Max. Okay. So I'm not sure if it has a dimension. Yeah, you could put in a dimension. Basically, if you want to add a dimension, you have to add a bracket over the empty bracket over here. So you can try, let's say, this way. Okay, it will give you the maximum rainfall from each month. So if you check over here, right, it's because you have 12 rows in here, right? And then you have 272, and then 103, 89, 260, right? So these are the values that we can get. So now we can try. Okay. Let's see if we can do value and location. Right, so it's going to give us the value is the maximum value of the rainfall, and the location are basically the location that has the maximum value. For example, January, you have the maximum value at the 3rd day, right? February, 2nd day, right? March was 25th day, 25th day, so on and so forth, right? So I would say, well, this, by looking at this problem, if you think about Excel, right? So Excel cannot solve this problem very easily, because even if you use the sort function, even if you find the maximum value, it won't give you the location of where the maximum value is, right? So you can see MATLAB can solve this problem very easily. So you can just do this value, location, or maybe we should use value days of the rainfall. Okay. So this is the example 3.3. And here we have 3.4, so climatology data. So climatology data is going to be a long period of time, right? Trying to find a pattern. The weather data has been kept reliably since 1850, right? That's a long time ago in the United States. But most of the reporting stations have been in place only since 1930 and 1940. So this is sort of like a weather station, right? It measures the wind speed, the rainfall. The rainfall should be down somewhere, right? It has a solar panel and so on. So the data is stored in the weather data XLS for just one location. You can use them to practice statistical calculations to find the mean daily precipitation for each month, the mean daily precipitation of each year, for the year, daily precipitation, and then find the standard deviation for each month for the year. I think this is still using the same data set, right? So let's do example 3.3 and 3.4. Okay, so now it's asking us to find the mean daily precipitation for each month, right? So now we have to calculate the mean. So let's add our comments, right? Total precipitation by month. And then here's total precipitation by year. And here is maximum precipitation and day of each month. Okay, so the next is we're trying to find the mean daily precipitation for each month. So an easy way to think about it is just to do mean rain. And again, we need to do 2 along the dimension 2, and we need to omit not a number. Okay, so this is how we can find the mean precipitation for each one. And then it also wants us to find the mean, basically mean daily precipitation, right? The mean daily precipitation for the year. Words. Okay. And then there's also year. It's just going to be the average or the mean of all of these, right? So the mean of the daily precipitation that we got from every month. So mean precipitation for the year. And then the standard deviation for each month and for the year, right? The standard deviation, STD, precipitation month. It's just going to be the STD, same thing. Okay, let's try to put here. Okay, so it says that W has to be a vector of non-negative weights or scalar 0 or 1. So let's see how can we do the standard deviation with a different dimension? Well, one way we can try is to basically just calculate the first row, right? So calculate the first row and see how the W works in the standard deviation calculation. So STD, let's see, rain. We said the first row can be just 1, and then the column, right? The entire columns. So if we use 1 here, or if we use 0, okay, so they are a little bit different. So the W, it seems like the default W is using 0, right? So then I think for our calculation, you can just use rain 0, which is a W value, the dimension 2, and omit not a number. So this is basically the function that we use to calculate the standard deviation for each month, right? Because it's averaging, or it's doing the standard deviation for each row. B for each month. And then also the standard deviation for each month of the year, right? So basically we want the standard deviation for the year. So we have to calculate everything, right? So if it's everything, is it a function of all that we just earlier show over here? So if you use the standard deviation of 0 all and 1 all returns the standard deviation of all elements of X, right? So a weight of 0 normalized by n minus 1, a weight of 1 normalized by n. So basically, you can just do this. Just do. So then it's going to give you the standard deviation of everything, right? So you can see that the help function can come quite in handy when we don't know how to run certain function, right? So CD for the year, whole year. Okay, so this is some more practice of the data set. I mean, as you can see, if we run in MATLAB, it's going to be much easier if we run it in Excel. Okay, so you can achieve all of these functions, or all of these calculations by just using the default functions. Okay, so the next is a generation of random numbers. So I mean, you may think that random number, why are they so important in our applications? So the random number, it's used a lot in signal processing, and also basically it's a random process, right? So in our applications, there can be random processes involved. For example, to group certain experimental results, you do not want to have the sampling just based on the order of the time, right? Because you could have systematic errors for the first several days, and then later you're using a different type of method, and then you could have completely different results. So then we may need to randomly group our experimental results to calculate or to look at the variance or the standard deviation. So to generate the random number, I think I showed this earlier, you just type in rand n, right? It will give you the n by n matrix. If you want to generate a random number with a different dimension, then you can do rand nm, right? So that's going to be n being the column, being the row number, m being the column number. Okay, so an example is to use the MATLAB to produce a random number between 0 and 40. So we said rand only give you a random number between 0 and 1. So if you want to do 0 and 40, you will actually multiply this by 40. Okay, so you can do, let's say, 5 by 5, then it's a random number, 5 by 5. Okay, so the next example is the noise, right? So I think this is a quite interesting example too. So basically, the random number is being used to simulate noise we hear on the radio. Okay, so for example, when you turn on your radio, sometimes you can see the background noise. It's sometimes quite annoying, but people also use that as a white noise, right? So adding the noise to data files that store music, or by adding this noise to data file that we store music, we can study the effect of static on recordings. Okay, so actually the MATLAB has the ability to play the music, and the music is formatted, right, in two types of data. One is the frequency, the other is the speed, okay, or how fast it plays. So basically this .mat file, we talk about data, right, storing the variables. Eventually you're having a .mat file. So this .mat file actually has the handle, basically handles music, Messiah, right? So I think it mentions somewhere that, yeah, we can play the Messiah by using the this handle.mat. So the way we do it is, you can see we already have the .mat file here. You can load it, just clear all the variables and CLC. Then we can load it over here and close it, right? So now you see the fs. This is, I would say, the speed of how fast you play the music. And then y here, this is sort of the frequency, right? So because our sound, right, our voice has certain frequency, and the frequency will determine the pitch, right? So if you load it, and then you can do sound y fs. Okay, so you can see that, I mean, the music, the sound effect is pretty good, right? And you can see that it's just two simple variables. So you can really see that everything can be digital, right? Or can be converted into numbers. So now we can do some quick play of this this soundtrack, right? So you can do, for example, you can multiply the speed by 1.5, right? So the play speed by 1.5, you will do fs multiplied by 1.5. Let's see what you can hear now. Right, so the sound effect is very different. Now you probably can think of the meanings, right? So that's how they speak, how they song, how they sing songs. Okay, so you can do even faster. For example, let's try 10 times. Now you can barely hear what's going on, right? So maybe 2. Okay, so as I mentioned, fs determines the speed, right? So how fast you play the song. And then the y here determines the frequency. So you can add some noise, right? By not the noise, I mean, if you add the noise, it's not going to be the speed, right? It's only going to be the value. So now we can try something, right? So we can sound still y, fs, the same speed. And then let's just start to add random number to the frequency. You can do rand. And then the thing is, the random number has to be added one by one to the y value, right? So you will basically create a random number that has this many rows of the that has this many rows, right? That can be correspondingly added to the y. So basically, you will do length of y and then 1. Okay, so you're adding some random number to the y here, right? And at the same time, this random number has the same number of columns, same number of rows, and then just one column. Okay, and then you can multiply this by 0.2, right? Just add a small noise here. Okay, so you can see, you can already hear noise, the background noise, right? So we can even add it bigger, right? Let's say, for example, 2. So now you see it's completely covered by, almost completely covered by the noise, right? This is also sounds like when we are tuning our radio, it's like in between two channels, right? It's a white noise that we hear, right? So you can see that we can easily add these noise or simulate noise in the soundtracks, right? So here the purpose is to try to study the effect of static on the recordings. Okay, so you can basically to simulate and also to find out how to reduce the static effect, right, to give you even better, let's say, sound effects. Okay, or maybe we can even try just listen to the noise instead of the original Messiah. Right, so this is how the noise sounds like. Okay, so this is example 3.5, and well, it didn't create a file, but we can easily do that, right? Example 3.5. So what we did is just load it and Dell or the handle, and then we played Messiah. All right, so we tried these, and we also tried adding a random number to create noise. Okay, so I named it as Untitled 4, but let's change it to example 3-5. Okay. So the next, I think the rest of the built-in function are just something that we probably won't use, very common. For example, there's complex numbers, right? I think for complex numbers, you may need to use that for some of the tensor or more sophisticated calculations, right? So basically, any complex number can be shown as a real part and shown with the real part or imaginary part, right? So I is square root of -1. So for example, if you type in sqrt -1, you're going to get that, right? But at the same time, if you do -1 to the power of 0.5, well, it's the same thing here, okay? So the complex number can be assigned by in MATLAB on command lines as follows: A equal to 2, B equal to 3, C equals A plus B multiplied by I, right? So let me see. Does it already recognize I? Let's see. Okay, you have A and B. Then let's try this. Okay. Yeah. So it can recognize I, right? So I is okay. I is recognized as the imaginary part of the complex number. Okay, it's predefined, right? So just like the pi value, I is also predefined. So you can find the real and imaginary components of a complex number, so real C, imaginary C, and to find the absolute value or modulus of a complex number. So for example, you have C value here, right? You can try real C. You're just going to get 2 imaginary C, right? Or absolute C, right? It's going to be the modulus, right? The absolute length of this complex number. And you can also find the angle or argument expressed in radians. So you can find angle of C. So this is in radius, right? If you want to find the degree, you're going to use this, or basically do this, right? So rad to degree angle of C, right? So you get the degree value. There are some other useful functions. For example, you can type in clock. It will give you the the array that tells you the year, month, day, hour, minute, second. This is a column, right? This is an array. So for example, if you name A equals clock. Okay. So today is 2025, August 15th, right? 10 a.m., 6 minutes, 11.644 seconds. Okay. So you can also do date. It tells you date directly with the pi, right? This is defined parameter or defined constant in MATLAB. Okay. So that's it for the built-in MATLAB functions. We covered quite a few basic ones. I mean, I have to say that we haven't got into the entire library of the functions that are used in MATLAB. And as you can see, there are so many of them. But a lot of times, if we want to build more sophisticated functions, we can build upon these simple ones, right? So we don't have to use the less uncommon ones. For example, the rad to degree or degree to rad, you know the conversion. You know that pi is 180, right? So if you know the angle in radius, right? So for example, you can just do this thing, divide by pi, and then multiply by 180. Multiply by 180. Right, it's the same thing. You don't necessarily have to do rad to degree conversion. You can just do the calculation by simple like mathematical multiply or divide. Okay. But I mean the help function or help feature is very important. So it can help you solve a lot of problems. And also if you really don't know some sort of or have sophisticated MATLAB questions, you can always check online, right? So as I said, MATLAB has a very good user community. People help each other and try to identify the most effective solution to your data analysis problems. So in this class, we covered these specific built-in functions, the basic math functions, the rounding function, the discrete mathematics function, the trigonometric function, data analysis, right? So we did several examples of the rainfall, precipitation, and so on, random number, complex number, okay? So I think that's it. So next class, we're going to focus on how to manipulate or how to work with matrix. We'll also go through some examples. That's it for this class, and let me know if you have any questions.